Ladies and gentlemen, welcome back to Amateur Repair Time. Now, if you were watching our previous video on this radio, we've been working on this cool old Philco. And when we got into it, we found that it had been reworked at some point, and regardless of when it's been reworked, the lines are just, the wires are just disintegrating in it. It's got a lot of rubber lines in it, wires in it, and they are in horrible shape. This thing's from 1942, so it's quite old by now. Someone has apparently replaced the rectifier tube with a diode, and they left the tube in so that the series, the string voltage would still light up the other tubes, I guess. So what I need to do is we need to start replacing some of these rubber wires. We're just not going to worry about where this goes for now. I believe the first thing we can do is we can get rid of one of these. This is coming from the field coil on the top and needs to attach to one of these connections. And they had something else on it running up here. So let me see, up to that. So we can pull that entire wire out. It appears that they had that hooked to the, at some point, the filter cap. Someone was saying, oh, you should just take everything out and then start all over again clean. Well, this is amateur repair time, folks. Yeah, so this appears to be the wire that ran over from that pin to connect to the filter cap, one of the filter caps. But as you can see, it's had better days. So that line there needs to come off. All right, so that is the one that wire needs to go to, but I've got all these other ones screwed up here under it that I got to replace before I can put this down. So this pin here had two wires coming off of it and a cap. So one of the wires was a yellow wire that goes all the way over here to here, okay? So I cleaned that up and put a new one, and it looked like this. I'm sure it was originally white, but it's yellow now. This is the one that we removed that apparently went to the filter cap. Okay, and then there was another one on that same lug that we're talking about now that would have, I guess that would be 1, 2, 3, pin 3, which is not actually used on the tube. They're just using that as a junction point, right? Which, you know, that's kind of hard to figure out on this line point-to-point soldering that they do. But they're just using that because it's an extra piece of metal that they can connect a couple things to. So that green wire is this one. And so it went from there up through the chassis to the antenna. Right, and it goes on that weird little leg there that sticks off the side. All right, now on that same pin, so those two wires there, on that same pin there was this capacitor, and it goes from there to there. I left it on there so we can J-hook the new one on. All right, now if you look at this capacitor, it is very clearly a Philco, so it's an original one. That is the part number, and it is very clearly a 0.1 microfarad. So you see that, right? It's a 0.1. 0.1, very clear to me. All right, so that capacitor is coming from here over to this tube, whatever it is. And let me see if I can figure out what pin that is. I can't see where it starts. Well, we should be able to figure it out just from that. So here's the schematic. This is the antenna that we were just messing with. See pin 4 there, how it sticks off to the side? So if you look over here, this is the antenna, and there's pin 4. And so one wire runs off and connects over to the 7C6 over in the corner. That is that yellow wire that we were doing. And then whenever it gets over there, there's a resistor connecting one pin to the next pin. All right, so that's the yellow wire that we replaced. And then we have the green wire that goes from the antenna. Now remember, they're connecting them on an empty lug down here. So we've just connected that to the antenna on that extra lug on here. And then there's a cap coming from there to the 7A8. So it's an unused lug here to there. That's what we were just looking at. And it is a 0.1. But if you look at this, the only connection is this, and it's labeled as a 0.01. Now, where we connect that, it's basically going from, oh, you know what? That's ground, actually. We're going to have to figure out what exact pin that's on to make sure we put it in the right spot. Well, that's got to be it. It's 0.01, and see how it says number 8 on it? That's not ground, but that is the neutral line, which I guess is ground. Well, anyway, if you go up here, of course it won't let me do counterclockwise, but if you go up here, you'll just have to take my word for it. If you look at number 8, it says condenser 0.1, 200 volt, right? So it's a typo on the schematic, but in the parts list, they get it right. Yeah, so I'm gonna go make sure that that is going where we think it is, and then we'll put a new one in. All right, so I'm about to hook up those wires that they had on the diode. I made a mistake in the previous video. No one corrected me on it. That's strange. Usually people tell me all the time when I'm doing things wrong, but so this is how the 35Z3 is on the schematic. You've got the 2 heater lines on the top up there. And then I was saying that this is the cathode and that's the anode, but that's actually wrong because they're drawing the tube upside down. That is the cathode and that is the anode or the plate. So the plate is going to these resistors. It's kind of strange that they drew it like that, but I'm sure it makes some kind of sense. Now, if you look at the other ones, you can see that the plate is usually drawn up at the top and the cathode is usually drawn at the bottom. But, you know, that's how the tubes are made. The cathode goes around the heater and then the plate is up at the top. But this one's drawn upside down. So I was incorrect when I said that. So the wire from the field coil needs to go where the cathode goes, and then the wire from the resistor needs to go where the anode goes. So the wire from the resistor needs to go to pin 2, and the wire for the field coil needs to go to pin 7. All right, so I put heat shrink tubing on the wire coming from the field coil. This is the other wire coming from the field coil, and it's on pin 7. And then the resistor over here that was connected to the diode is on pin 2. I replaced the wire that was on pin 1 because it was all screwed up. It comes over here to this side of the resistor. I believe that's the, that would be the heater. And then this is the other side of the heater. It runs off to here, I guess. And then the other ones to make the string. We replaced those two. I put the cap in that we were talking about. You can put a little spaghetti on it. I need to replace this. We need to figure out where that went. And then we need to replace this one, and then we'll be done with this socket at least. I need to measure those resistors in there to make sure they're all right. Or I guess there's just one. I need to measure to make sure it's all right and replace it if necessary. And then I think what I'm going to do with the filter caps is just run lines back over to here, because they were supposed to mount right here. I don't know where they had them mounted. I don't know what they were doing, but that one wire that we were talking about was sticking up here somewhere, so whatever. But I'm going to run them. I'm just going to run 2 lines to whichever pins they go to, and then run them back over here so I can mount them over here where I've got a little room. Well, it's going from bad to worse, folks. The field coil is no good. So it's supposed to be 500 ohms. It is not. It's open, which you can see how. I mean, it's just decaying. It's a damn shame, too. The thing was pretty nice shape. So I'm going to have to put a different speaker in it and rig up a load for that field coil or something. I don't know. But I'm just going to keep going through it like I was, and we'll figure out the speaker thing. I'll have to get another. That's probably a 3.5 or a 4-inch speaker. I'll have to research how to do that. People have been telling me in the comments the best way to do that, but that's a real downer. I was hoping that we could be able to save that, but what can you do? All right, so we were up to here, and that attaches over here. So maybe we got to figure that out first, so I can go ahead and mount whatever we're going to mount to get rid of that field coil before I bury it all back underneath this cap and all the stuff that gets mounted here, the oscillator and the 2 caps mainly. Yeah. So that sucks. All right, folks, I've been messing around with this thing, and there's just so many wires screwed up. I decided I need to basically get rid of all the junk first. So this side over here, everything appears to have not been disturbed, so everything hasn't broken apart yet to the point that it can short anything, with the exception of that one, but we're good there. So all of our problems are over here in this corner. So I took out the caps that were there. I've been working on this a while, so I'm talking several weeks. So I don't know if I mentioned, but the field coil is screwed up. I tried taking it apart and digging it out. It's broken in there somewhere. I was hoping it would just be like where the lug is or something. Nope. So we're not going to be able to use that. So we removed that, the transformer, all kinds of stuff. I've removed a couple of the caps, and I've replaced the deteriorated wiring. So this red one, and there is actually a blue one under there too that routes under it that I've replaced. I don't know if you can even see it. See it up in there? See it? So nice new wiring. Yeah, it ends up over here. Nice new wiring and these. So I think what I'm going to do, since we need to come up with something to replace that field coil, we're just going to have to rebuild that part of it. You know, and if you watch the first video, or the first part that we did of all this, I was making fun of this guy. Not really making fun. I was just saying that it was way too much. I wasn't going to do it. That he had taken everything off of his and then started from scratch. And one of the comments, somebody said, oh yeah, it's all screwed up. You should just take everything off and start from scratch. And I thought, that's crazy. Yeah, I don't want to do all that. But you kind of got to take at least a bunch of it off, because the wires are so deteriorated. Look at this. Look on my table here. Look at all that. That's rubber off of the wiring. Absolutely nuts. So I think what we're going to have to do is just work through the power supply first. It looks like most of this, the wiring is going to be intact. We'll be all right. But this power supply is where all the problems are. So we have this across the line cap here. This 04, we'll call it. One side attaches to the switch, and one side attaches to the resistor. Now this resistor is a special resistor that's 2 parts. It's basically a resistor with a center tap, right? So if you look, the cap is attached there, but also the power cord is attached there. Well, in this model, it doesn't have a clock. And didn't we figure out it? Oh, it does have a lamp. I see the lamp up there. So where this cap is that we've already put on is also where the power cord needs to go. I believe when we got this one, wasn't the power cord already removed? Like I said, it's been a while since I messed with it. And someone has written on the front of the resistor, 45 ohms from here to here, and 130 ohms from here to here. So this is 40 instead of 45, and it should be 120 altogether. So that's a little off, but that's all right, especially if you think about how the line voltages went up over the years. So where this cap is where we need to attach our power cord. And the cap is right there. One side of it is on the resistor, and the other side is on the switch. That's that new cap we put in. So our power cord is going to be in that exact same spot. And that will allow the switch to work, and everything will be hooked up like it should be. Okay. So coming from there, the center tap of that resistor should feed the light bulb, should be across that resistor. But then it should also feed the cathode of the, or not the cathode, that's actually the anode because this is drawn upside down. The anode of this 35Z3, right? Now, I can't remember which pin that is on this socket, but we already did all that too, right? So if you look, the center tap of the resistor is heading down to that pin on the tube, which is the anode. Okay. Now, if it has the lamp, the 2 wires for the lamp should also go across that part of the resistor in parallel. And if you look very carefully, see that little wire running off up to the top right there? And then I guess there's a white wire there. Is that one we replaced already? Is that what I'm seeing here? Oh no, it's a sleeve on it. All right, so that's the 2 wires running up to the lamp here. Now the reason that they're kind of helter-skelter is because, oh, never mind, this is not the same one. I was thinking this is the one where it moves. I've had one where that actually moves. The lamp is on the dial indicator. Okay, so that is hooked up fine. We'll have to check those wires again just to make sure everything's not shorted or falling open. So we're up here. So the rectifier is going to do its thing, right? And the other side of the switch has a line that's going to run off, hit 2 caps, and then hit the other side of the string. So I went and looked up the socket pins of the heater lines on the string, on the different tubes. So from the resistor, the end of the resistor, we should head off to pin 1 or 8 of the 35Z3. If you look, this wire here is just, I don't even know what the hell that goes to. If you look, it comes off there, comes down, and that is pin 1, I believe. Isn't that how you do it? You start at the notch, and then you start counting clockwise. So it's pin 1, okay? Now pin 8 is that red wire there that I have replaced. So from there, that should run off to pin 2 or 7 on the 50L6 GT. And if we look here, if I can, there's so much in this setup here. Where is our notch? Yeah, there it is. So, is that pin 2? Can we tell from the top? Probably not. One, 2, 3, 4, 5, 6, 7. So we should have 2 here that surround the notch that don't have anything on it. They call this too much booty in the pants. There's too much stuff down in here. I cannot see through the phone if that's pin 2. Let me make sure. I'm just trying to double, triple check everything. It is. That's pin 2, I believe. Maybe pin 7, but either way. Okay, so the other side of that is this pin. So this wire here continues the string. It's heading on. And boy, it looks like it might be deteriorated, is it? That gray one down there? I think I lost it in the mix here. It must be going to this socket. Hey, y'all clicked on the video. You can't complain too much. The rest of them are 1 and 8 again. So that is pin 8. Yes. So it's connecting to pin 8. So pin 1 it's just unbelievable. It's unbelievable, folks. I'm trying to get a good gander at pin 1. That's it right. That's it right there. So it's this wire here. And off it goes. And it runs over to pin 8 on this one. All right, there. So pin 1 is that one. So it's another wire that snakes under this thing. That's it there. Slightly deteriorated, but not the end of the world. And it runs to that pin right there, which is pin 1. And then finally we have pin 8, which is that one. It's kind of scary looking, isn't it? Is that correct? Why would they have resistors on it? That's pin 8. Yeah, there are resistors there for it. Okay, so it snakes back around and ends up here, which is probably an unused pin that they're using to junction off to something else. That might be a good place to... That might be a good place to attach some of the filter caps or something. Spins around to here. So they're using unused pins on this socket, I guess. And it's that yellow wire that we've replaced, which runs back over here and is attached to pin I cannot tell. 1, 2, 3, 4, 5. Pin 6, which may be the same type of thing going on. Shouldn't we have ended up back at our switch? Or did we? Is that what the yellow wire is here? a freaking mess. Nope, it's not the yellow wire. So you see the issue here. All right, I gotta look through that last one more time, because we should end up back at the switch, and we didn't. Aha! I have figured it out. We did end up back at the switch. If you look, those two pins are tied together. So they've tied pin 8 and pin 7 together. And then you see that rubber, that black rubber, blue rubber wire coming off of that, snaking down under there. And then see it right there. It connects to the other side of the switch. So that the string is intact. So all of this is together. This is the neutral side, which is running up to connect to some of this stuff. My thought is, with the field resistor out, which we have, our voltage should stop right here coming out of this rectifier. So we should be able, if everything's clean and we're not shorted anywhere, and if we bring it up slow and watch it, if we've got the 5 tubes in, we should be able to get glow on them. We should be able to put the power cord back on, and then we should be able to measure voltage right here at this cap. Right? Even if the cap's not there. We can measure from here to here and see if our rectifier tube is working and if our string is working. And that's as far as we've gotten so far. So I'm just trying to minimize everything, get everything back to basics so that I can test what we've got and work through it slowly and try to rebuild the thing. I think most of this is still in there. I haven't cut all of it out. What I messed with was the wiring around here and around here. So that's what we need to mess with. There's our output transformer, the speaker that's missing, the field coil that's missing, etc. I'm going to try to replace the field coil with this resistor. We'll see how that goes. So I need to install this capacitor, and I need to make sure this capacitor isn't there. I would like that, and we've got this disconnected for sure. And then bring it up really slow. That's the plan. All right, folks. So I have carefully checked. All of those wires are fine. I have this one I need to mess with, obviously. And we've got a stray one here. You know, we got stuff cut out here. But pretty much I've got it isolated because that field coil is disconnected. So without that, we're not going to get the 95 volts there, but we'll get something here, right? So I have installed this capacitor. I looked up this pin out. Pin 7 is the cathode. And then it's connected to the other side of the switch. Well, if you look, the other side of the switch connects to a bunch of things, actually, including the main rest of the schematic. So that is this wire here. It goes all the way down here. We replaced it earlier. Comes down to here, it jumps around, it does all kinds of stuff, and then it comes back over to here. So I even checked it with the multimeter. That is actually where the negative of the capacitor is supposed to be. And then it's supposed to be connected to pin 7, which is right next to it. So I just put this right on the bottom of the socket. Now, I know what you're thinking. A lot of you people would do it a lot cleaner than that, and it'd look a lot nicer, right? But remember, this is amateur repair time, and I've never had to work on one that's this screwed up. But I think what I'm going to do, I'm going to break out my trusty Variac over there, so we can bring this thing up slow. And I'm also going to put a amp meter on it, so I can see how much current it's drawing to see if anything's shorting. And we should be able to watch that, and as long as it doesn't start shorting, we should be able to bring it up and just see if we get glow on our tubes, which I have reinstalled. And see if we get any kind of anything out of this rectifier. It could be the rectifier's bad too, you know, but I've probably got some more. So I think that's where we're at. So I'm going to try to plug her up and we'll see what happens. Oh, I've installed the cord back. That wasn't there whenever we got it because they had the sense to cut it off. And I popped a little grommet in there. If you don't have any of these, I tried to get some that were made in the USA, but I couldn't find any. You know, I'm big on made in the USA. So these are made in China. But I got this grommet assortment, all different sizes. So that we don't have to worry about this cord getting all screwed up. All right, so I think we're about ready to mess with it. Now, I know a lot of you are frightened for me right now, but if you're seeing this video, I must have lived through it. So don't be too worried. So here we go. All right, now if you haven't seen me mess with this before, boy, you're in for a great treat. Remember, this is amateur repair time. So I have a Variac. It's on 0 volts right now. I have it plugged in, and it's fused. And then I have this ammeter plugged into it, and then the radio is plugged into that. So it's going to get its power through that meter and from the Variac. And I've had all kinds of people complain about everything. This is not turned sideways. That's how it's supposed to be. The feet are on the bottom of it. Okay, so that's the first thing. I've got it set on its lowest setting so it can go up to 1 amp. That's the meter that it's using. So we're going to turn it on. This thing should only pull like 0.2 amps or something like that. I didn't do the math, but it's not much. All right, and that's with it fully working. So all we're trying to do is get the tubes up and warm. So we'll see here. So first thing I'm going to do is turn it on and see if we blow a fuse or this starts shorting or what. And remember, it has 0 volts really. Okay, so it's just a switch and a volume knob, and the volume knob's not going to work because the whole meter is not doing anything. I mean, the whole radio is not doing anything. So I'm going to slowly turn it up, and let's see if anything starts shorting once we get up to like 20 volts or something. We're at 30 volts, 40 volts, 50 volts, 60 volts. That might be enough to get some glow. Keep in mind too, if you've got a bad connection on any of them, the string won't work. Nothing, but it could be our voltage is too low. Here we go. All right, we're at 120 volts. Nothing. These are the lock tools that Shingo was always complaining about. And you know, we should be getting our lamp on too. If the lamp's not burnt out. Well, sure enough, and I have seen this before, the rectifier tube, the heater is burnt out. So basically, this is not connected. So since that isn't connected, they're all in series, so you won't get, I mean, most of you watching this, I'm sure know all this more than I do, but you can't get any of these to light up if any of them are burnt out. And so this one, the heater element is open on it. And the way you can test it is just check the resistance between pin 1 and pin 8. So on this one, for instance, the resistance is infinite. It's not connected at all, and that's why the power won't run through it. I pulled all the other ones and checked them, and they have varying measurements. So some of them are 10, something like that, which I guess would be these 7-volt ones. And then this one was much higher. It was like 40 or something. It moved around a little bit, but this one is completely open. So I'm going to see in my great stash of bulbs, tubes, do I have a 35Z3? I'll bet I probably do. I found one. I had one. Just one. But I tested it, and it is not open. But this one is. Now, an interesting thing, I hated that I had to do this. Originally, it was a 35Y3. This isn't labeled anymore. You can't tell what it is. But it must be a 35Y4 because it has an extra pin on it. So these two are the heater, and then this one is the anode or cathode, and this one is the anode or cathode. This extra pin, which is pin 4, so you start at the dot and you count clockwise. 1, 2, 3, 4. Pin 4 is just an extra pin that they added in so that there's a tap for a light bulb, right? But this is an old radio. This is like a 1942, was it? 1942. So they just wired it up differently. They just wired it across that resistor. But here's the problem. On the bottom of the radio, they are using that pin as like a tie-off point. So what they would do a lot of times is if it doesn't use all 8 pins or whatever, if like pin 4 isn't used, you would just use that to junction some wires and jumper some stuff around because there's no pin there. Well, that's fine until you put a substitute tube in it that has an extra pin on it. So 35Y3 is what's supposed to be in there, but 35Y4 appears to be what was in there. But this pin has stuff soldered to the bottom of it. They're just using it as a junction. So you're not really, it's not a good substitution. You're running a voltage into a spot that's not supposed to have a voltage because they're just jumpering wires there. They may have done it in such a way that it worked fine. I don't know, but not wanting to repeat what I see as a mistake, I cut the pin off of my 35Y4. So I didn't have a 35Y3. I'm sorry, 35Z3. I had a 35Z4, which is the updated version with the extra pin. That must be what this is too. They must have already done that. This is a Sylvania. This is a Philco radio. Apparently, you would think originally they probably had Philco tubes in it. So the tube's probably been replaced at some point. So anyway, I cut the pin off, and now we're ready to try it again. So we're going to turn it on, and we're going to watch our amps over here to see if anything crazy happens. All right, so I'm at 0 volts. Let's try it. I didn't measure them, but I measured all of them before, and they were all fine. And then I measured this one out of the radio, so they should all be linked together now. Now, we won't get any sound or anything. Half of the radio is not even hooked up. We're just trying to see if we can get glow out of the tubes. 20 volts. Yep. Look, I already got it on the light. So we got some glow on the bulb. Need to watch that to make sure it doesn't go crazy. It is going up a little bit, but nothing crazy. I'm watching the meter. Okay, I think that's about 120 volts. And yeah, we've got filament glow. If you've got one, I guess you must have all 5, or it wouldn't be able to do that. Okay, so we apparently have the string working. You can kind of tell. I can see it a little bit. So next thing I want to do is I want to check the voltage that we're getting out of the rectifier. So let me turn it back off, turn it up on its end so that we can get to that capacitor, and we should be able to check it across that. Okay, so I was able to check it, and we are getting, I have no clue if this is correct, we are getting 176 volts right there out of the rectifier. So we've got about 120 going in, and we're getting 176 out. Then it runs through this field coil, and it should have 95 on the other side. So I'm sure there can be math done to figure that out, but I think that sounds about right. Let me see if I can figure out what the DC voltage should be coming out of the rectifier if 120 is going in. All right, so I checked. Our input voltage was a little high. It was like 128. I turned it down to 120, and then this lowered to about 168. So, and then I looked online, and people are saying that usually when you have 120 going in, you got about 170 coming out. So I think we're right on the money. So I think what we've done is we've gotten this figured out and this figured out. We've discovered that our field coil's messed up. Our speaker can't be used because of that. And I think a lot of this is going to be all right. But that's where we're at right now. We're up to here. Everything's cool up to here. And we're not blowing fuses or anything. And we've removed almost all of the wiring that we need to. So I need to, I think I'm just going to use a resistor for it. They say if you do this, it can add some noise. But I don't really know how to get the right choke for this to replace that. So I think I'm just going to use this and see what kind of noise we've got. They're saying online that if you up these capacitors, it'll filter out more of the noise. But we'll see how it is. I'm not really that worried about it. Usually, if things are noisy, where there's a little hum going on or a little buzz in the background, it doesn't bother me at all. But we'll see. We can always adjust it later too. So we got to add this in and then check what happens afterwards. And then we've got to get our output transformer back on with a, well, probably a different one, with a correct speaker. Big job. But I feel good that we got the string working, and we got we figured out the rectifier tube was bad and worked through that. So that's where we're at so far. Oh, and by the way, the amp gauge went up to 0.2. That was as high as it ever went, which again, is probably about right. All right, folks, so there you go. This has been this week's Amateur Repair Time. Join us back next time when we'll get farther into it. I think I'm going to sneak in we haven't finished this, and we've been working on it for quite a while. I also still have my Majestic radio over here that we need to finish up. So we've got 2 unfinished projects here, but my buddy Dennis wants us to work on an 8-track player that he's trying to put in his car. So we might do that and take a little break from this, work on the 8-track player, and then come back to this or come back to the Majestic. So we'll see. So if anybody's got any ideas, how would you do it? Because most of you certainly probably know more about it than I do. So what's your opinion? Can we get away with this sand resistor here, or do we have to find a choke? But leave your comments down below. Let us know what you think, and we will see you next week. Hey, make sure to check out my brother Donnie. If you don't know about him, my brother has his own channel here on YouTube where we lately have been doing a lot of work on mobile homes, and we've even been touring like some new mobile homes and things like that. A fun time is had by all. So go check out his channel. And if you like watching me tinker with these old radios and I don't know what I'm doing, check out this video where I did something similar a while back. We'll see you on the next one.